Okay, well, let's begin. Hello, everyone. This is another in our series of webinars. My name is Mike Barcik, and I'm here with, and we are on this particular webinar going to talk about the Georgia 2020 Commercial Field Guide, which is just a terrific resource, user's guide to the much more complex two choices we have for a commercial energy code, both ASHRAE 90.1 and the IECC. And we'll show just a couple other resources too that you might find useful. And so Ali, one thing that it occurred to me that people may not know what we look like. So I thought I'd put a picture of us up here so that you can, okay.
Yeah. That looks about right.
Yeah, I think so.
It's got the height difference.
I think maybe your audio is on.
Oh.
Yeah, there you go. That's better.
Can you hear me?
I can't hear you now, but I did a minute ago.
Yeah.
So that's all right. No, that's good. People are entertained by that, I'm sure. So having said that, one thing I always want to point out is if you're interested in the two commercial energy codes in Georgia, it's ASHRAE 90.1 2013, and that's the 2013 version of 90.1, or the commercial chapter of the IECC 2015, and the 2015 has a couple Georgia amendments that come into play as well. So I'll just try to make that point. You can choose either path essentially as your compliance path. But you have to kind of stick with one. So either you go the IECC and a couple Georgia amendments pathway, there we go, or the 90.1 2013 version. And there are no amendments to 90.1 2013. But what we're here to talk about is some of the great resources that I think you can take advantage of. They're all free and they're all at southface.org. Okay, so Ali, southface.org, that sounds like a really simple thing. So when I click there, I'm going to immediately get to this. What do I need to do to get to here?
You're going to go to education. It's going to be on the top bar. Just hover over education, click on our courses, and then you're going to see a series of collapsible windows. Click on the energy code one with the plus sign next to it, and then you'll see the Georgia Energy Code Supplements document. Right.
So let's go do that just so everybody knows what you're talking about. Let me go over here, and there's a picture of us. So let's go back to the home page. We'll click on the home page. Is that going to take us home? Yeah. So there's the home page, our beautiful building, and you said I'm supposed to go across here.
Yep. Right where it says education.
Education.
And then click on our courses.
And I'm just going to click on it, our courses, and you scroll. You see some examples of different things we're involved in. Did I go to the wrong one?
I think you might have clicked education.
I think I did. So if I click on courses,
yep,
that would actually work. Well, this is good. This is good to do this live and learn how anyone else could screw this up. If there's a way to screw it up, I think I'm the guy. So anyway, there's energy code, and there's several energy codes, but at the bottom is the Georgia Energy Code support documents, just like you said. So when I click on that, that's going to take me here, and it talks about the grant and everything and the education effort, and it's got a lot of you can read on down, and the format of some of the trainings we've done, and so on. So what we have over here is information that people might find useful. From the commercial side, I would say this is a valuable one. These are the slides from the actual commercial training. So that's, I think, a pretty good detail. The rest of this up here is mostly I think it's all residential. And then if you'll click down to tools and support, there's the big thing we want to talk about, which is the commercial field guide. There's a residential one and a commercial one. And there's also the same in Spanish, which is kind of nice. And then finally, there's also, we had some good money to do some research grant for multi-years, and we created some good tools. And one of the things that we ran into a lot was combustion safety issues in light commercial buildings. So I wanted people to be aware of this there's a little workbook if you kind of know the code and you want to do some number crunching, it does it for you. But more importantly, I think, is this document, which is about 50 pages of helping to explain whether this equipment is safely installed in this building. It's not so much as the equipment bad or good, it's the context of how it's installed. So there's a lot of pictures and a lot of case studies. I think that's a really important topic. Take advantage of that. If you're interested, there's a few other resources down here as well, but this is all under the section called the Georgia Energy Code support documents. And Ali, there's something else I want to show people, this resource button right here. So I got it pulled up somewhere. Technical resources. If you click on resources, you go to technical resources. Right here under, I'll collapse it here, under Advanced Commercial Building Initiative, there's a ton of good information. If you work in the, light commercial world, and light commercial really 100,000 square feet easily could apply, 50 for sure. These are a lot of good information about retrofits and how we blower door test in commercial buildings, field guides, lots of support tools, information about controls, and there's some case studies and so on. The one I wanted to particularly point out is this one. I'd like you to read that for me.
That one's the Energy and Water Efficiency Project Implementation Verification Checklist.
Wow, that is the greatest title. That is really impressive. And yeah, even though it was created, if you click on this, it's a checklist, and it was created for commercial, but light commercial, but it would absolutely work for homes as well. But when you click on that, let me take you to the beginning of it. It's basically, if you've got a building and you're thinking about, you're the client, or maybe you're a verifier helping to help a client, and you've got a subcontractor that's going to do some of this work, the idea is, how do I ask the right questions for a particular improvement on my building? And what are the things I want to be aware of? What are the questions I want? Instead of just relying and hoping that the sub is going to get all these, tick all the boxes, we're going to be a little assertive and make sure it does right. And as an example, here's a list of some of the different items that show up. So for example, you've got an existing commercial building, and you've got, say, a flat ceiling, lots of leaks and so on, and you decide you want to retrofit spray foam along the roof line. Well, there's 2 pages of sort of questions you should ask and details you should be aware of, and I think that's really, really helpful. Likewise, maybe you want to just improve the flat attic and then add more insulation. There's a section there. Or you want to improve your foundation, or you want to replace equipment. Like, I want to put a new air conditioning system in. What are the questions I need to ask? What are the things I should be looking for and asking for? And it's like just a little bit of sort of, self-motivation here can make a big difference. So here's a list of a bunch of different improvement items, and some of these have to do with water saving, and some have to do with, most of them are energy. But these are great little documents. So for example, what's this first one? Retrofitting spray foam insulation. What are the things you need to be aware of about thermal barriers and ignition barriers? What should we do with the old insulation up there? Do we need to get it out, or can we keep it? I recommend getting out because of air quality. Checking for roof vents, and so on and so forth. So all of these details can kind of really help make your project be a winner, as opposed to one where we throw money at it, the contractor does a job that's inadequate, everybody's unhappy, and it never really gets done right, and it just sucks extra time. So be assertive on the front end. Good things will happen. So here's a re-roof with continuous insulation above a low slope roof deck. We want to have more R value on the roof and things like that. So this is good information. And also exterior walls. So I just wanted to point that out. This is all wrapped around light commercial, but it could be used in a lot of buildings. and just, again, take a look at the questions that it's asking, or the questions you should be asking. All right. Having said that, that very exciting looking document, the one that we're going to go to is the commercial field guide. And when you click on that, it will pull it up, and you can of course download it if you want, but this is what it looks like. And I'm going to pull up a version that I already have opened right there, and I'm at the very tail end of it. Pop to the top. And I think what I really like about that, wow, that's too big, is that it has obviously a cover that's similar to the residential one, but it's the commercial one. And it says it's based on ASHRAE 90.1 2013 with the Georgia supplements and amendments. It should also say IECC 2015. I realize that's kind of a little typo on the cover. It's not, it's just missing information. So it's definitely more written around ASHRAE 90.1, but we did add content that says if there's something different about this in the IECC, we try to point it out. So it's really, it really is more of a user's guide to 90.1, but I still think it's valuable even if you're using the other code option. So I'm gonna zoom and kind of walk you through it here. And Ali, what's our, I realize I just now, how many minutes?
We've got about, let's go for 20. Let's see how many.
Minute about 10?
Yeah.
Okay, that's perfect. I want to try to get the right amount.
Yeah.
So the field guide, again, I was kind of a disclaimer here. It's not trying to be all things to all people. It is not the entire code. It is really more salient, pertinent aspects of the code that, you know, if you have a limited time that you can pay attention to the code, these are some of the more important issues, and also help understand what the key elements are. It's basically three main sections: envelope, lighting, and mechanical. So we'll hit those very quickly. I would say probably the most useful part is probably envelope, just because it's got a lot of pictures and diagrams, but there's some stuff on the other part too. All right, so unlike the code, this is laid out by component. So there's an introduction, kind of explains the codes, but basically if you have a wall, what type of wall, okay, it's an above grade steel framed wall, come here to page 11 and we'll tell you all the details about that particular, you know, that construction. And often it'll make references to multiple parts of the code, and we tried to write it in non-code language. And we always try to put pictures. So that's, I think, the big appeal, is that it's you know, pictorial, and it's easy to read and understand, hopefully. Now, I will say the code is complex for sure, but you can see a lot of this content is all based on envelope details. Down here, we get, the next section has to do with simple HVAC requirements. And then the last one, a little bit about water heating, and a little bit about electrical and lighting. And again, I also want to always point out to everybody that there's a great tool that you can use and for showing compliance on the energy code, and it's CommCheck. So I have it here, but maybe I'll just show how you get it, because I had it. You get it from energycodes.gov, and you go to CommCheck, and you can either download a version of it, which is great if you're just using it yourself, but if you're sharing with a project team, you might want to use the web-based version, which I actually have open here. And let's see, it's going to tell me it wants to relaunch it probably. So you, excuse me, it asked me twice. And it's going to pop up, and it's going to say, okay, you know, which code are we talking about? Either the 15 IECC or 90.1, and then which Location is this building. Stick it in Georgia. Pick a city in Georgia that you want to build it in. Let's go for Montrose. And it'll figure out what climate zone and all that stuff. And then basically there's tabs over here for envelope. You always have to tell it before you do anything what type of building it is and how many square feet it is. So you got to always do that. So let's just say it's a retail building. And it is, 8,000 square feet, that kind of thing. So once you've done that, now you can go into envelope and you can sort of build the description, and then when you're all done, you hit check compliance. So you can actually do some simple trade-offs of this. And I wanted to make sure we covered it because later on I'll refer to it. When it comes to lighting, you have to figure out how you're going to do your budget, and you'll learn there's a simple version and a hard version. I think we're in the building area method right now. So our basically it's going to say 8,000 square feet times 1.26 watts. And that, oops, did I not do that? Oh, wrong one. I think I'm so zoomed in I can't see everything I want to see here at the moment. But there we go. We'll pick the building area method and we're okay. That's all we have to do is, and then when I go to envelope over here, to lighting, it calculated our budget for lighting is 10,080 watts. And then I just simply have to describe my lighting schedule, and I put in that information and blah, 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 fill in all the information. How many lamps per fixture? How many fixtures do I have? 50 of those. And let's put in 50 of those. Each fixture is 88 watts. I don't know. Oops. And it calculated that I've used up about 44% of my budget. So anyway, that's a great way. I'm going to always recommend you use CommCheck to show compliance for lighting. We'll talk about some of the content, and that's what the field guide does. But you should also consider using it for envelope because it's really great. You can create a roof, et cetera, et cetera, et cetera. So I'm going to cancel that for the moment. Now I have to find out where am I. Oh, what are we looking at today? So we are looking at that one. Okay, so we'll scroll through the content of this, and here's a quick summary overview of the code and the different compliance options. And again, notice it says CommCheck is highly encouraged. It's a really good idea. And then you figure out your climate zone. Georgia's climate zones 2, 3, and 4. Get it from that list. Then ASHRAE, you find out, well, there's different kinds of spaces, or Georgia has a definition that says, you put a small amount of cooling in, small amount of heating in, or you're connected to a space thermally that's indirectly conditioned. So that defines that. And basically, in the ASHRAE world, most commercial buildings are what's called non-residential. Some have people sleeping in them. That would be like a dorm or a motel. Those are residential commercial buildings. And then there's a special category. I call it freeze protected, but they call it semi-heated. It's like a warehouse that you put a tiny, tiny amount of heat in. And when I say tiny, I mean so tiny that when it's cold out, the inside of the building is going to be 33 degrees, so the pipes won't freeze, but that's all. They're not going to be 34. So it's not much. And I think that's probably the big stuff we want to look at there. So here we're into components, and now we see examples of what are the prescriptive R value requirements if the insulation is entirely above the deck. And you'll notice it's 25 and 25, and in climate zone 4, it's 30. That's a big deal. Those are big numbers right there. That's significant. But that's the best place for roof insulation to be. And that's definitely more than the previous code would require. Okay, scrolling on down. Here's different kinds of buildings. Metal buildings, they kind of have their own requirements. And you can either meet an R value or a U factor. And we'll show you if you want to do U factor, there's a table. Big thing with metal buildings is they want this thermal spacer block. And it's a minimum of 3 or 3.5, something like that. I thought it was 3.5. If it's a roof with an attic, it's basically 38 or 49. This is the ASHRAE version. And the IECC only requires 38 for all climate zones. So there's an example where ASHRAE is a little bit more stringent in climate zone 4 than the IECC is. But there's other places where it's the opposite is true. Okay, here's mass walls. And depending on whether it's a residential occupant commercial building or a standard commercial building, a mass wall may have more or less requirements, usually more for residential than the continuous insulation. That's what the CI stands for. And then, you know, metal building walls, pictures, steel frames, steel studs. Probably one of the most important things to get across here is steel studs require more R value. They require R13 in the cavity plus a continuous insulation of R5. So that's an important detail. Or any assembly that meets the U factor, and I'll show you that in a second. Wood frame walls, basically just R13. They're gonna pass code, and it depends on your climate zone. It depends on your occupancy type. Below grade walls or basement walls, basically no real requirement unless you're in the colder part of the state. And again, those are prescriptive. You could trade that off with CommCheck. Mass floors, continuous insulation is required. And then other opaque, steel frame floors, again, R30 in that example. Wood frame floors are R30 in that example. Slab on grade, if it's heated, then you got to put insulation on the edge. And this is very uncommon, but this is where you have a radiant tubing system in there. Okay. Normally they're unheated, and unheated slabs basically do not require insulation by ASHRAE until you get to the cold part of the state. So that's, again, that can be amended to 0 or traded off to 0. Or the version of the table from ASHRAE is, here it is for climate zone 2, here it is for climate zone 3. So again, you can do any roof assembly that's let me zoom in on that so you can see that. Any roof assembly that's R25 continuous, or any roof assembly that's continuous that overall has a 0.039 U factor or lower. So that's basically how that works. That's for that type of building. That's for non-residential, residential, and sort of free. Likewise, steel frame wall. R13 plus R5 is your prescriptive code, or any steel frame assembly with any combination of insulation that does not exceed 0.077. That's the nature of the beast. You're still prescriptive if you can meet that. And there it is for climate zone 4. Okay. So we're kind of wrapping up. There's requirements for doors, non-swinging doors like roll-up doors, and then glazing. So now ASHRAE 90.1 allows you up to 40% of your wall can be glass, and you can still stay prescriptive and not have to do a trade-off. If you need to go more than 40%, we recommend you try it with CommCheck. We actually got a parking deck to, no, not a parking deck, I'm sorry, a commercial building that had a parking deck, but it was like an office building, and they had significantly more glass. And we were able to show that if we insulated the spandrel glass really well, we were able to get almost like an 80% glass building to pass code using CommCheck. So you can do trade-offs. You can also do a full-on energy simulation using what's called the energy cost budget method. In terms of glazing, it's again 40% of the wall area is the upper limit. The other thing that's new is they have this requirement. So your U factor has to be 0.50 or less. Your solar heat gain is 0.25. Your visible transmittance over your solar heat gain, that's a new spec. That has to be at least 1.1. And let me see. Go back to those graphs, I mean these tables right here, and you'll see where this is climate zone 3. And you'll see where the details fall in. Those are different U factors based on the type of window. They always have that solar heat gain of 0.25. And they also have this new thing, which is kind of like saying we don't want you to use a super tinted window, because tinted windows will block solar heat gain, but they'll also block visible light. So we want more visible light than we want solar heat gain. Okay, I'll zoom back out of this. About 5 more minutes? Yeah, I think that's perfect. So to kind of wrap up the envelope stuff, then it just kind of goes through components. And Windows, the challenge is always trying to get the glazing manufacturer and the frame manufacturer to work together to give you the actual performance data. That's a bit of a challenge with commercial buildings. Details for like residential style attics, insulation has to be fully installed correctly. Thickness of insulation, we don't want to have to compromise for can lights, so you want to make sure they're airtight and IC rated. You're not allowed to put insulation on top of a suspended ceiling. Your exterior wall has to be protected. Loading docks require weather seals, and a lot of this on the energy code is about air sealing. There's a lot of details on air sealing, and including windows, but just more importantly, details. Vestibules are generally required. There is one big exception that ASHRAE has that's not in the other code. So ASHRAE says you can exempt a vestibule if you're in climate zone 3 and it's less than 4 stories above grade and less than 10,000 square feet. So that's a certain size, medium size, small building, I guess, that you can exempt a vestibule, but that's not in the IECC. And the rest of this is talking about the simplified mechanical approach, where if you can just, if your building is 2 stories or less, and the floor area is 25,000 square feet or less, you can just say yes, no, not applicable for the next 18 boxes. You can tick the box on them. You're done. You don't have to do anything else. So one single zone system, that's pretty typical, like a packaged rooftop unit or a split system maybe. That would still be a simple system. Variable flow equipment, there's certain turn down capability they want you to have based on the size of the fan, and it comes from a table. But assuming you can meet that, which shouldn't be a big deal, some form of throttling ultimately. Equipment efficiency, there are tables of equipment efficiency, and those tables for the IECC have been replaced by the ASHRAE tables. Here's an example of one. Minimum equipment efficiency. Economizers, the new code loves economizers. I don't, but they do. So you can trade it off with more efficient equipment. So that might be one way to not, but they like you to use economizer controls. Obviously, you need something that looks at both temperature and moisture, not just temperature. Heating equipment, not a big deal here, pretty standard stuff you can use. This one is about exhaust air, energy recovery. If you have a certain amount of exhaust air and you're operating your building less than 8,000 or more than 8,000, I think that maybe you should say more, then what is the percentage of throttle in essence that you need to have, or energy recovery, I guess is the big thing. So at some point you have to kick in with energy recovery, and you got to be able to catch at least 50%. So that's a pretty decent doable thing, and this is usually bigger airstreams. Thermostat, basically programmable 7-day-a-week thermostat. Supplemental heat on a heat pump, just like we saw for residential. You don't want the supplemental heat to run unless it's cold. They define cold as 40 degrees. And you can't use reheat for moisture control in the simplified approach. You don't want to use it in general. They want something to shut things off like a programmable thermostat or a time clock for any piece of equipment, more than about like a motel. 15,000 BTUs an hour is like a, big window unit. So anything bigger than that, you got to have the programmable control. Pipe insulation, yes, and it has to be protected from the elements. Well, we've definitely seen failure on that before. Duct insulation, pretty easy. I think the most you'll ever see is R6, and of course sealed properly. And balanced, here's a key one. Make sure the air is delivered where it's supposed to be, within 10% of design. And then automatic dampers, in our climate zone, I think a lot of times they can be gravity dampers, but dampers on intakes and exhausts. And interlock thermostat, we don't want to have two thermostats in the same room, one heating, one cooling, so that makes sense. Optimum start is, we always call it the Monday morning. This building we're in right here, Ollie, a certain Monday mornings you come in, it's really hot.
Oh, yeah.
A week ago. And so this idea is with optimum start on bigger systems that it knows that it takes longer to recover from setback on the Monday morning than it will on, say, Tuesday, Wednesday, Thursday. So, and then last two, demand control ventilation. This is one where you're making sure when a space has a lot of variable occupancy, like a conference room or a training center, certain types of spaces make a lot of sense. There's a whole lot of people in it, or there's not many people. A lot of people exhale CO2, the CO2 levels go up, the damper, a sensor detects that and opens the damper and brings in more fresh air. And all they're doing is they're applying this really good idea to some more spaces. So it has to be any space over 500 square feet that has a certain amount of people per 1,000. That's not much. So that's a good thing. Door switches, again, this is essentially things like, this loading, or not a loading dock door, but it could be a loading dock door. I was thinking we had a restaurant that was a hamburger stand and they had a roll-up door out onto their patio. And we certainly wanted to make sure that when the weather was nice outside and they rolled the door open, that the air conditioner in the dining area did not run. So that's a good example of that. Okay. And then lastly, a little bit, not much on water heating here, no real big changes here. Pipe insulation, a few places. And then a couple things on electrical, but I think we're kind of wrapping here. So I'm just going to say, use CommCheck, it's your friend. There's a case study of an example in here, how to account for lighting design, how to use CommCheck. And certain types of lights are exempt from the code, but you still got to do them. And a lot of stuff with controls. This version of the energy code got big on controls. So with that, I'm going to say that takes you through the content of the residential field guide. It was also kind of a summary of the code, but if you really want to understand the code, I think if you read this, it should make sense. Hopefully it's written in understandable language and it's laid out in a way that sort of makes sense. So that was our goal at least. And again, this is what it looks like. And this is where you get it, right there, that website right there. Okay, so Ollie, I think we're going to wrap this webinar, unless you have any other thoughts on there.
Nope.
This is what we're talking about.
Again, everything is on our resource page, so please feel free to check it out and find anything else that kind of helps if you're looking for.
Excellent. Thanks for your time.
Thanks, everyone.